So we're going to start our 2D simulation of our wind tunnel by opening Workbench. Then we're going to go to Fluid Flow Fluent. And then we're going to start in our Geometry tab. So you're going to work from the top down. And we're going to go to New Design Modeler Geometry. And you see down in the bottom left, it's starting the Design Modeler. It usually takes a little bit. Since we're working in 2D, I'm just going to click the Z-axis and it'll bring us into our X and Y plane. The next step, we took everything in centimeters, so we're going to change the units to centimeters. And then we're going to start by drawing 4 lines. The important part here is just making sure that they all connect at their points. And then the next step is we're going to dimension horizontally each one of these lines. Now, before I actually input the dimensions, we're going to take one line all the way across. And so what we're going to end up doing is constraining that line via midpoint to the center of our origin. That just makes calculations and what we have to do later easier. So, we're going to go and put in each of our dimensions that we got. So we calculated or measured it to be 31.5 length, 63, 32, and 60.5. Now we have that. It's symmetrical about the y-axis. Our next step is to draw 5 vertical lines. You'll know it's vertical when it has the V. And then we'll be doing another midpoint constraint of each of these lines to those points, the endpoints of each of those smaller lines we made. Now we're going to do a vertical dimension across each. And now remember that the settling chamber, the beginning and end of the settling chamber are the same. The end of the settling chamber is also the beginning of the contraction chamber, which means it's going to be the same, which means we're going to have a lot of repeat values here. So, it was 55.5 is what we measured it to. 16.5 for the test section. And then this final one, so in order to get the half angle correct, trigonometrically you would solve for it. However, you can also, if you just measured the beginning of the diffuser, which is also the end of the test section, and then the end of the diffuser, you can input those and then it'll automatically go to the proper half angle. So I need to make sure that it's at each point. The end of each line terminates at each of these top points. Now, in order to actually generate the geometry from the sketch plane, we need to get rid of all these construction lines that we made. The easiest way is to go under Modify and go to Trim. All you're going to do is go crazy on deleting out, or trimming out rather, each of these lines that were made. So now we have a clean interior that's dimensioned properly before. So we go to Concept, Surfaces from Sketches. You're going to click this little drop down plus. You're going to click this Sketch 1 and you're going to apply that to your surface sketch. Next step is to click Generate, and now we have our wind tunnel. So we go back to Workbench, we go to Mesh, and now we edit the mesh. And again, you'll see in the bottom corner it's loading. It may just take some time. So now sometimes it'll open back up the design modeler part, and what you just need to do is go down to the meshing step. So you right click on mesh, you go to insert, you're going to go to method, you're going to click anywhere in your sketch, it's going to apply the geometry, and now underneath method we're going to change that from quadrilateral to triangles, and we're going to generate. Now sometimes it doesn't show up immediately, so you just right click the mesh and now you see all those triangles are massive. That's not going to give us an accurate solution. So we go back down in this bottom left, you'll see details of mesh, and we're going to change that to 0.015 and regenerate. Next step is to go up to this box, to the edge. We're going to left click and then right click to create a name selection. This is going to be our velocity inlet. Do the same thing on the end, the diffuser, create name selection, and this is going to be our pressure outlet. Now the final step of the meshing is to select each of our walls, create a name selection, and we're just going to call this walls. We're going to regenerate just to make sure it's saved, and now we go back to Workbench and we update our mesh, and now we edit our setup. So we're going to use double precision and one solver process for this one. So now our mesh has automatically come in to the next step. So our first stop in setup is going to be under models. We're going to right click and turn energy on. We're going to change our viscous model to K epsilon and enhance wall treatment. We're going to click OK. The next step is going into our boundary conditions. So this blue is our velocity inlet, this red is our pressure outlet. So we're going to go under boundary conditions, inlet, velocity inlet, and for 30 Hertz we calculated that it is 1.8436 meters per second, and you're going to apply that. You want to leave everything else the same, absolute, magnitude, normal to boundary. Then you're going to go to outlet, and while we're not changing anything in the pressure outlet, this would be where you could choose your gauge pressure, or if you wanted to account for the ambient pressure on the outside or change it to a specific one, you could do that. So we're just going to close. The next step, you're going to go down here under solution into initialization, and you want to make sure it's on hybrid. Then you're going to go to more settings, and we'll change our number of iterations to 50 just for this specific one. You could go higher or lower, and you're going to hit OK. The next step before we actually calculate is to go to solutions, and then under run calculation we want to change the number of iterations. So I'm going to put 150. Doesn't matter which one you use, but you're going to put whatever. It should converge beforehand. And then you're going to right click down on run calculation here, and you're going to go initialize and calculate. So it's initialized and now it's calculating, and now our calculation is complete. So now in order to derive the actual information we need from this simulation, we're going to go down left under results, the graphics drop down, we're going to right click on contours, new, and now this is where you would make a contour plot of any specific thing. So you could do your pressure, your velocity, any of that. So for this one we'll go velocity, and we want our velocity magnitude, and we want it throughout the entire body. So you're going to click everything and then save and display, and now we have a contour plot of our velocity magnitude throughout the wind tunnel. And then you can also double click on this bar here, the color bar, and you can change the type to a float, so that makes it easier to see, and then you can raise the precision to get more exact numbers if you choose. So we're going to close that. Now the next step is to graphically see what's going on here. We want to go to our XY plot, under plots and results, you're going to go new, and so now we need to take everything across the center line of this. So we don't have anything here for the center line, we don't want to do any of these surfaces, so we're going to go new surface, line rake, and so now here is where I said it would be easier if we do it across the center line, or midpoint in the design modeler, to do the origin. So what you would do to get the exact, you would figure out what the exact x value is here and the exact x value is here. So all you do is take the total length of this, divide by 2, and then you just take the negative and then the positive of that, and that will give you your endpoints. But for this demonstration, I'm just going to select points with the mouse, and we're going to go roughly in the middle, here and here. So now you see it auto-populated everything here. So we want to make that 0. We want to make this 0, that way we're at least on the center. And this should show now. You're going to create it, you're going to close. So now we're going to click line, velocity, save plot. So now you'll see I clicked a little far off on the side, so that's why you have this gap here, but when you actually input the proper numbers, you will get this will be connected to the y-axis. So now this is the velocity, the chart of the velocity, and you would make multiple of these for any sort of calculation you need, whether it be pressure, your static pressure, dynamic pressure, total pressure, and your velocity magnitudes. And that is it.